For a kids game, Pokemon has a surprising amount of depth and a lot of convoluted mechanics. There's the experience required to level up, EVs are stat experience, IVs are DVs, damage ranges, but chief of all of these are the catch mechanics. You see the ball shake and whether you caught the ball or not, but it's really not clear to players what happens behind the scenes. The only information that the player gets is the status of the Pokemon was afflicted, or the amount of health that they had, and that generally speaking, Pokeballs should be better the more expensive they get. So, on this episode of Over-Explaining Games, we're going to be explaining Gen 1 Pokeball mechanics. In this video, we're going to do the following. To start, we're going to examine some potential myths in the community, then we're going to look at the math, then we're going to address those myths, and finally we're going to take what we learned and explain how to apply it to your gameplay. So to start, here are some myths that I've heard around the community. The first is that in Gen 1, Great Balls are better than Ultra Balls. Now, obviously on the surface this seems ridiculous, but this myth has permeated the community so much that I think it's worth looking into. The second is that HP doesn't really matter, and I mainly see this on content creators when they just throw Pokeballs at really easy to catch Pokemon, and they don't worry about hitting the Pokemon, they just continuously throw Pokeballs until they land. And the third myth is that status effects are very important. Obviously this seems true, but let's look at the math and see if this really is accurate. And before we move forward, this is your math alert. If you want to skip all the math and just go to the conclusions, go to the timestamp on screen. We're going to need a blackboard for this one. And, as always, my work is linked in the description. This time it's in a Jupyter notebook with all the nice graphs and codes so you guys can play with the numbers and hopefully have a look at what I did. So to start, this is a general overview of the catching process. The process has 3 parts, and we'll call these parts A, B, and C. So for part A, we generate a random number, M, based on the Pokeball that you're using. So for a Pokeball, that number is between 0 and 255. For a Great Ball, it's between 0 and 200. And for an Ultra Ball, it's between 0 and 150. Compare that number to a number that's generated based on the status effect of the Pokemon that we're calling S. So S is 0 if there's no status effect, it's 12 if the Pokemon is burned, paralyzed, or poisoned, and it's 25 if the Pokemon is asleep or frozen. If S is larger than M, then the Pokemon is automatically caught. If the Pokemon is not caught, then we move to part B. Now we make another number N equal to M minus S. If N is larger than the catch rate, then the Pokemon breaks free. This means that Pokemon with a smaller catch rate are more likely to break free, and Pokemon with a larger catch rate are easier to catch. If the Pokemon doesn't break free, then we move to part C. What we do is we generate a new number and we compare it to a ratio that's based on the Pokeball type. The new random number is just any random number from 0 to 255. We'll call that number K. Now, the ratio is 255 times the max HP of the Pokemon divided by B times 4 times current HP, where B is a number based on the Pokeball. If the Pokeball is a Great Ball, then B is 8, and otherwise it is 12. Now, if we compare K to the ratio, if K is less than this ratio, then it's a catch. Otherwise, the Pokemon escapes. One really important note here is that because this is a ratio, for Great Balls, if we lower HP below half, it doesn't do anything because this ratio will always be larger than 255. And similarly, for Pokeballs and Ultra Balls, if we lower the HP beyond 1/3 of the max HP, then it does nothing as these always result in a catch. Another side note is that if you use a Master Ball, it just bypasses this whole process. There's a myth that there's a 1 in 256 glitch, just like there is for critical hits or for 100% accuracy moves. This is not true. The Master Ball is hard-coded in the game to always catch. It doesn't do any funky math or play with the numbers or anything. It just always catches. So how can we use this? Well, using a Pokemon's catch rate, current and max HP, status effect, and the ball you're using, we can determine the exact probability of catching the Pokemon. So there are 4 possible outcomes from running the catch formula. We could catch the Pokemon due to a status effect, which we'll call X. We could have the Pokemon flee due to the Pokemon's catch rate, which we'll call Y. We could catch the Pokemon due to the HP ratio, which we'll call Z. And if all else fails, the Pokemon is released, and we'll call that W. These are similar to the A, B, and C processes we described above, but the difference here is that these are the outcomes, not the processes, and that only one can happen, meaning that they're mutually exclusive, and that they can't be broken down any further, and that they encompass all of the possible scenarios. In probability, this is a concept called elementary events or atomic events. So the probability that we catch the Pokemon is just the probability of the 2 events in which the Pokemon is caught at the end, and those are X and Z. So is this just probability of A plus probability of C? Well, not exactly. And the reason is that probability of X is equal to probability of A because A happens first, but sometimes we never even reach part C. So probability of Z is the probability of 2 things occurring. The first is that when we reach C that C works, and the second is that we reach C in the first place. This is also known as probability of not A and not B and C. We can use the conditional probability formula to turn this into probability of not A times probability of not B given not A times the probability of C given not A and not B. So how can we solve this? Well, keep in mind that the finished product is in terms of x and z and not in terms of a, b, and c. But we can get that the probability of not a, which is the same as the probability of not x, is equal to 1 minus the probability of a, since it either happens or it doesn't happen. This is just called the not rule. Probability of a is just the number of random rolls where a succeeds divided by the number of rolls, total. Remember that the number of random rolls where it succeeds is equal to s, which is the status number, as all of the numbers below s are a success and s and above are failures, and that the number of total rolls is j plus 1, where j is the maximum roll for a Pokeball. So for instance, because an Ultra Ball is between 0 and 150 inclusive, there are 151 total rolls. So for instance, a burned Pokemon with a Great Ball, that's 12 over 201. For the last portion, we know that probability of C is not dependent on A or B at all, as it's a new dice roll and then the ratio is completely different. So probability of C is going to be equal to the ratio divided by 256, and the reason is that there are 256 different rolls and that each roll has to be less than the ratio in order to be a success. So we can pre-compute the ratio, and then the probability is just the ratio divided by 256. Of course, if the ratio is negative, then the probability is just 0, and if the ratio is greater than 256, then the probability is just 1. Now, all we're left with is probability of not B given not A. This is actually really hard. And the way that we're going to do this is first we're going to use the conditional probability formula. So this is probability of not B given not A is equal to probability of not B and not A divided by probability of not A. And hey, look, we already have the denominator. For the numerator, we have to look at how these events work. So for A, we know that M has to be less than S for A to succeed. And therefore, for A to not succeed, M has to be greater than or equal to S. And another way of saying that is that M minus S is greater than or equal to 0. For B to happen, we need M minus S to be greater than the catch rate. So for B to fail, we need M minus S to be less than or equal to the catch rate. So not A and not B happens when 0 is less than or equal to M minus S is less than or equal to the catch rate, which happens in a total of catch rate plus 1 divided by J plus 1 times, where J is the maximum roll for the Pokeball. And of course, this formula is floored at 0 and limited by 1, as all probabilities are. So now we have the full formula solved. We can just plug in probability of catch equals probability of x plus probability of z into a function, and we get an output for each catch rate, status effect, Pokeball, and HP value. And now that we have that, we're going to make graphs for different scenarios to compare the balls. I only graphed 4 very common catch rates. These are 255, 190, 90, and 3. There are other catch rates in the game. 45, 60, and 75 are also very common, but they use the same principles and they aren't different enough to include on their own. Each graph keeps status effect and catch rate constant, while different Pokeballs are in different lines and different percents of max HP are within each line. So to start, let's look at the graphs for Pokemon with catch rates of 255. Examples of Pokemon with this catch rate are Caterpie, Weedle, Pidgey, Rattata, Spearow, Ekans, and many more unevolved Pokemon. As you can see, regardless of status effect, all 3 balls can get up to 100% catch rate by lowering HP enough. For Pokeballs and Ultra Balls, you probably should lower it around 33%, and for Great Balls, 50%. There's very little difference between the balls, and essentially no difference between Pokeballs and Ultra Balls, except for status effects. Honestly, looking at these graphs, just use a Pokeball, but lower HP first. Next up is the 190 catch rate bracket. Examples of this are Pikachu, Vulpix, Paras, and Slowpoke, and others in this bracket are generally unevolved Pokemon that are a little bit rarer to catch. As you can see on the graphs, Great Balls are clearly the favorite. Ultra Balls do slightly better than Pokeballs across the board, but Great Balls do great. Of course, with no status effect, Great Balls cap out at around 95% catch rate, but if you have any status effect at all, Great Balls are the best ball for Pokemon of 190 catch rate across the board. The next bracket is the 90 catch rate bracket. Examples of this are Fearow, Arbok, and Sandslash. These are usually Pokemon that only have one pre-evolved form but are fully evolved. As you can see from the graph, without status effects, Great Balls are better than Ultra Balls above 45% HP, but they're worse below 45% HP. With status effects, Ultra Balls and Great Balls are much more similar above 50% HP, and Ultra Balls are much better below 50% HP. Ultra Balls benefit both more from the HP drop and from the status effects. Which Pokeball you use on these Pokemon depends on how much you want to wear the Pokemon down with statuses and HP drops, but in most situations you should be using the Ultra Ball. The only time you shouldn't is when there's no status effect and you don't want to waste the Pokemon's HP, but this seems kind of ridiculous and you only get about a 30% catch rate with Great Balls anyways, so I think in this situation Ultra Balls are better. Finally, for the Pokemon with a catch rate of just 3, these are just legendaries: Articuno, Zapdos, Moltres, and Mewtwo. My first observation is that Ultra Balls are always best, and without statuses, these are nearly impossible to catch. Even with the minor statuses, burned, poisoned, and paralyzed, this is still really difficult. The Ultra Ball caps out at around an 11% catch rate. With major statuses, sleep and freeze, Ultra Ball caps out at around a 19% rate. So HP does next to nothing here. It increases by about 5%, but status effects are the real kings here. So why does this happen? Well, if we look at the formula, if we don't catch due to status in Part A, there's about a 1 to 2% chance, depending on the status, that we make it past Part B. Otherwise, the Pokemon escapes. Therefore, HP matters very little in these calculations because we almost never get to Part C. Another overall interesting point, if we look at all the graphs, is that Great Balls cost 3 times more than Pokeballs, and Ultra Balls cost 6 times more than Pokeballs, so Pokeballs are always the more cost-efficient option, then Great, and then Ultra. So, going back to addressing the 3 myths, the first myth is that Great Balls are better than Ultra Balls. This is only a half-truth. It depends. On Pokemon with high catch rates, this is true. With low catch rates, it's definitely not. And Great Balls are much more HP efficient, but when you add status effects, Ultras become much more powerful. The second myth is that HP doesn't really matter. This is a half-truth. Even for high catch rate Pokemon, HP is always a big deal. Always lower HP to 50% for Great Balls or 33% for Pokeballs and Ultra Balls, except on legendary Pokemon. For them, HP is an extremely marginal increase. Just status the legendary Pokemon, preferably with sleep, and then start throwing balls. The last myth is that status effects are very important. This is true, especially on Pokemon with low catch rates. But even for Pokemon with high catch rates, all you have to do is status the Pokemon, and then you have to lower its HP less in order to catch it. So overall, status effects are basically always helpful. So how can we use these results to help our gameplay? First, for easy to catch Pokemon like unevolved Pokemon, just lower their HP to 1/3 and throw a Pokeball. For moderately difficult Pokemon with catch rates of about 120 to 210, just lower their HP to 50% and use Great Balls. Lowering their HP any further doesn't do anything, and all of the other balls are just worse. For difficult Pokemon with catch rates of about 30 to 120, always use Ultra Balls, lower their HP to 33%, and sleep if possible. For legendary Pokemon, don't really worry about the HP, but put them to sleep and throw Ultra Balls only. You won't be able to have much luck otherwise. Lastly, if you want to be the most money efficient, always use Pokeballs. But remember that you can die against wild Pokemon, so only do this if you're comfortable and you're okay with it taking a little extra time. However, Pokeballs are always the most money efficient given the amount of balls that you're expected to throw. And that's all I've got for you today. Hope you all enjoyed this episode of Over Explaining Games. Have a good night.